everyone. Today we'll be talking about the geometrical applications of calculus. So far what we've learned of calculus is how to differentiate and integrate. And what we're going to learn today is how we apply that differentiation to graphing. So what the differentiation tells us about graphs. So to start off with, we're going to be learning about increasing and decreasing values of a graph. So over here we have two parabolas, and as you can see in the first parabola, this part of the parabola is said to be decreasing. Can you see how that's decreasing over here? And what we're actually saying by saying it's decreasing is that the gradient of the tangents is negative. So you can see if I drew a tangent anywhere along the graph of this portion, can you see how it's going to be negative, the gradient? And now what's really important to know is that the gradient of the tangents is actually the same thing as the first derivative. So everything we've been learning about the first derivative, that actually gives us the equation for the gradient of the tangent. So therefore, when we say that the graph is decreasing, that's when the gradient of the tangent or the first derivative is less than 0. And in the same way, we can say that when the graph is said to be increasing, that's when the gradient of the tangents, so a tangent over there, is positive. And that's when the first derivative is greater than 0. So what's important for you to know is that the first derivative that we've been learning, that's actually the same thing as the gradient of the tangent. So when we find the first derivative of equation, we're actually finding out the gradient of the tangent, the equation for all of those gradients. So therefore, when the gradient of the tangent, the first derivative, is less than 0, we call that decreasing for the graph. Whereas when the first derivative is greater than 0, we say the graph is increasing. And now, just a side note, some of your teachers and textbooks may use f-x or y- instead of dy on dx. These are ways to write the first derivative. Now, in the New South Wales syllabus, we use dy on dx. So that's why throughout these modules, we'll be using dy on dx. But these are actually just the same way, a different way of writing the same thing of the first derivative. Okay, so important thing for us to remember is that the gradient of the tangent is actually going to be the first derivative. That's something we have to remember for all these portions. Okay, so just to reiterate what I said, remember when we said that the first derivative is greater than 0, that's when the graph is increasing. And that's quite easy to remember because you think to yourself, greater than 0 is increasing. Whereas when the dy on dx, the first derivative, is less than 0, that's decreasing. So less than 0 is decreasing, whereas greater than 0 is increasing. Okay, let's go through an example together now. So in example 1, we want to find the x values where y equals to x squared plus 2x minus 1 is increasing. So we think to ourselves, well, increasing from what we just learnt is when the first derivative is greater than 0, which means we need to find the first derivative. So what we write is essentially dy on dx is greater than 0, except we need to work out what dy on dx actually is. So in this case, take the 2 down. That's 2x plus, that's just going to become 2, and the minus 1 just disappears. So we get 2x plus 2 is greater than 0. And now we'll just be working with this portion of the equation. So just move the 2 to the other side. We get 2x is greater than negative 2. Divide both sides by 2. So now we get x is greater than negative 1. So what we've actually worked out is whenever we sub a number bigger than negative 1 into this equation, that part of the graph will be increasing. Okay? Alright, well let's go through some questions together now. So in question 1, we want to find the domain over which the function y equals to 4 minus x squared is increasing. So then we think to ourselves, okay, well increasing, that's when the first derivative is greater than 0. So that's exactly what we write, dy on dx, and then we want to work out what the first derivative is. 4 just disappears, take the 2 down, so we get negative 2x is greater than 0. So in your exams, I actually want you to write it like this. So write it as dy on dx. So you're showing the examiner, you know we're working out the first derivative, and that's greater than 0, okay? So we know we want to find when the first derivative is greater than 0. And now we're dividing both sides by -1. And remember, when we divide or multiply either side by a negative number, what happens? Exactly, we have to flip the signs. And that's why we've gone from greater than here to less than. Yeah, can you see that? How we've gone from 2x is greater than 0 to 2x is less than 0 over there. So now we just divide both sides by 2. And finally, we get x is less than 0. So what we've worked out is whenever we sub a number smaller than 0 into the equation, the graph is going to be increasing. Yeah? Okay, all right, let's go on to the next question now. So in question 2, we want to find the domain over which y equals to x cubed plus 12x squared plus 45x minus 30 is increasing. So remember, once again, we think increasing, okay, that's when dy on dx is greater than 0. So we want to find the first derivative again, which in this case, take the 3 down, dy on dx equals to 3x squared plus 24x plus 45, and the minus 30 just disappears. And that's greater than 0. Well, having a look at that straight away, we can see it's going to be a quadratic because we have an x squared there, which means we're probably going to need to factorize. Now, before we factorize anything, what do we always do? Exactly, we always need to simplify. So having a look here, we have 3, 24, and 45. Can you see anything that we can divide it by to make it simpler? Exactly, we can divide everything by 3, can't we? So if we divide everything by 3, we get x squared plus 8x plus 15. Can you see how that's so much easier than this one up here? So now we can just use the cross method. And we just want two numbers that add to give us 8 and multiply to give us 15, which is going to be, it's going to be 3 and 5. So then we just write it as factors like that. So we have x plus 5, x plus 3 is greater than 0. And that tells us that there's going to be x-intercepts at minus 5 and minus 3. And now we just need to draw a really quick sketch. So just remember, this is just a really quick sketch that you do at the side of your book. It's nothing major. You don't have to label the x-axis. It's just for yourself. So at -5 and -3, we know it's intercepts. There's no negative in front of the x squared, so we know that means it's positive. So it's going to look like this. And now we've drawn it, we think to ourselves, when is that bigger than 0? Well, it's going to be bigger than 0 when the graph is greater than the x-axis. So when it's above the x-axis. And can you see how that's going to be this part over here and this part over there? Whereas this part in the middle, can you see how that's below the x-axis? So this part's less than, whereas these parts are greater than. Which means the graph is greater than 0 when x is going to be less than -5 or greater than -3. And because they're actually separate areas, you can see that we want to write the answers separately. So we have x is less than -5 and x is greater than -3. Okay, I just want to point out once again that this graph that we've drawn here is just a sketch to help us answer this part of the question. It has nothing at all to do with the original graph itself, okay? All right, so let's move on to question 3 now. In question 3, we want to find the values of x for which y equals to x cubed plus 6x squared plus 15x minus 1 is increasing. So we know now that increasing means when dy on dx is going to be greater than 0. So we want to find the first derivative of that. And the first derivative is going to be, take the 3 down, 3x squared, plus take the 2 down, that's going to be 12x plus 15 is greater than 0. And once again, we want to simplify. So having a look here, what can we divide it by? Exactly, we can divide everything by 3, can't we? So that leaves us with x squared plus 4x plus 5 is greater than 0. Now, this can't actually be factorized using the cross method, but if you have a look here, can you see anything within it that maybe we could factorize? Exactly, there's actually a perfect square there, isn't it? Because we actually have x squared plus 4x plus 4, and that's our perfect square, and we just move the plus 1 to the other side, which means we can just make that into the perfect square of x plus 2 whole thing squared plus 1 is greater than 0. And once again now, we want to draw ourselves a little graph just to answer our question of when that graph is bigger than 0. Now, how we draw this is we think, well, when it's x plus 2 whole thing squared, that means it just has a vertex at minus 2 over here, but because it's plus 1, the whole graph gets moved up by 1, which means the vertex now becomes negative 2, 1. So can you see how the vertex is actually above the x-axis? And since there's no negative in front of the x squared, it means it's a positive graph, which means the entire parabola itself is actually above the x-axis. So what does that mean for us when we're trying to find out when this graph is bigger than 0? Exactly, it means that the graph is actually always bigger than 0. Can you see that? Since a vertex is bigger than 0 and the whole thing is, everything else is above the vertex, it means the entire graph itself is bigger than 0. So it's saying to us that it's actually always positive. So therefore, we say that the curve is said to be always increasing. So can you see how, when we look at this, because the vertex is actually above the x-axis, everything is positive. So therefore, our answer to what values of x is going to make it increasing. It's actually all values of x would give it an increasing. Or you can write, therefore the curve is always increasing. Okay, let's go through what we do when it's decreasing values. So in example 2, we're going to work through finding all values of x for which y equals to x squared plus 4x plus 2 is decreasing. So now, remember how decreasing was when dy on dx was less than 0? So it's exactly the same as when we're working out increasing, but now we're just working it out for less than 0. So as the same as before, we want to find the first derivative. So dy on dx in this case is going to equal 2x plus 4, and that disappears. So we have 2x plus 4 is less than 0. And remember how now we're working with this portion of the equation? So just move the 4 over, so we get 2x is less than negative 4. Divide both sides by 2, and we get x is less than negative 2. So we know that whenever x is less than negative 2, this is when this portion of the graph is going to be decreasing. Okay, so let's work through some questions together now in relation to this. In question 4, we want to find where the function y equals to 2x cubed minus 6x squared is decreasing. Okay, so decreasing, remember, dy on dx less than 0. So in this case, the first derivative, take the 3 down, you get 6x squared minus, take the 2 down, 12x less than 0. Once again, we see the x squared, quadratic, we're going to have to factorize. Before we factorize, always simplify. So we've got 6 and 12, and should jump out at us straight away, we can divide everything by 6. So divide by everything by 6, we get x squared minus 2x less than 0. That's quite easy to simplify. We can just take the x out of that, and we get x bracket x minus 2 is less than 0. And now we want to do ourselves a quick little sketch to help us visualize the answer. So we know there's going to be x-intercepts at 0, and then at 2, and there's no negative in front of it, so it's positive. Looks like this. Okay, when is that less than 0? Remember, that's below the x-axis. So that's going to be, yeah, exactly. It's going to be this portion here, isn't it? Which means that for this graph to be less than 0, x has to be in between 0 and 2. And because it's actually in between these numbers, that's why we write the answer as x is greater than 0 but less than 2. Whereas before, when we had this portion and this portion, we wrote it separately, whereas when the answer is actually between two values, we write it together. Okay, so now we've worked out that whenever we sub a value in that's between 0 and 2 into the original equation, that's when the function is said to be decreasing. Okay, let's have a look at question 5 together now. So in question 5, we want to find the values of x for which y equals to x to the power of 4 minus 8x squared plus 7 is decreasing. So we know now that's why dy on dx is less than 0, which in this case is going to be 4x cubed, that's going to be minus 16x, and that plus 7 is just going to disappear. So 4 and 16, anything we can simplify? Exactly, divide everything by 4. So we get x cubed minus 4x is less than 0. And you can see here we can take out one of the x's because that's a common factor. So we have x bracket x squared minus 4 less than 0. Now, can we factorize this? Of course we can. Using the x squared minus 2 squared method, we get x plus 2, x minus 2. So it's a difference of 2 squares that we're using here. Okay, so now we've finally factorized it as much as we can. Into this, we always want to do a little sketch here now. And we can actually see there's going to be 3 intercepts here. We've got 0, minus 2, and positive 2 there. So we have 0, negative 2, and 2. And since there's no negative in front of the x, we know it's going to be positive. Positive means that this graph ends going positive. Okay, and that's true for all your graphs. If it's positive, the last part is always going up, and I think that's a really good thing to note. So at negative 2, it has to cross there, come back down to cross a 0, and finally go up to cross at 2, and that's a graph we have. Now we can go, well, when is that less than 0? Well, you can see it's going to be less than 0 here, but is there any other parts that are going to be less than 0? Exactly. This part is also less than 0, isn't it? Which means that our final answer for this is going to be when x is less than negative 2, or when x is going to be between 0 and 2. So we actually have 2 answers where x is going to be between 0 and 2, or x is less than 2 over here. So what we're saying is whenever we sub values into that, into the original equation, that's when the graph is going to said to be decreasing. Okay, let's go on to the next question now. So in question 6, we want to find the values of x for which y equals to x to the power of 3 minus 2x plus 10 is said to be decreasing. So by now, we should all be very familiar with this. This means dy on dx is less than 0. In this case, that's going to be negative 3x squared minus 2 is less than 0. And so we move the 2 over. So now we have negative 3x squared is less than 2. And now we want to get rid of the negative sign from the 3. So what we've done is we've divided both sides by negative 1. And remember how we said that's when we flip the sign? So that's why we have 3x squared is greater than negative 2. And now I want you to think about this. That means that x squared is going to be greater than negative 2 on 3. But what's interesting about this that I've just written? Exactly, because x squared is actually always going to be positive. Can you imagine that? So any number squared is always going to be positive, isn't it? Which means that x squared is always going to be greater or equal to 0. So if this portion here is always bigger than 0, and this here is negative, can you see how x squared is actually always going to be bigger than negative 2 on 3? Yeah, because this has to be positive. So if this is negative, this is always going to be bigger than that. So therefore, based on that, we can say that since x is in this equation is always going to be bigger than negative 2 on 3, therefore x at any value is going to make the graph decreasing, which is the same as saying that the graph must be decreasing all the time. So it's actually really important just to keep your eye out for these things, whereas you get that equation and you can see that we can't actually solve it because you can't square root a negative number. But if you just recognize that since x squared has to be positive, we can see that therefore it must satisfy the equation all the time, and that's why the answer for this is y is decreasing all the time.